Okay, let's start now. Good morning, good afternoon, and good evening to everyone. Welcome to the Advances in Climate Change Research Symposium. My name is Chongfang Wang. I am the Publishing Director from CRY, a Beijing-based open access publishing joint venture of OCEAN and China Science Publishing and Media. In July this year, the journal Advances in Climate Change Research received its first impact factor, which is as high as 3.967. So we wish to thank all of our authors, reviewers, and readers for making it the journal of choice. That's why we organized this symposium in the name of the journal. So in this symposium, together with the editor-in-chief, Professor Qin Dahe, and other renowned scientists, we will explore the most recent research advances on climate change and the relevant policy interpretation. After that, we will have a panel discussion. We have invited some of our author representatives, the executive editor, and the publisher of the journal to discuss and share experience and advice on how to get published in this journal. But before we dive into the academic lectures, let's take only 1 minute to learn about the history of the journal. Xiaoyang or Ran, can you please play the video about the journal? Okay, thanks again to all of you who have contributed to the success of the journal. Now, without wasting any other time, let me please welcome Professor Qin Dahe, the editor-in-chief of the journal, to open the lectures by his talk, Advances in Climate Change Research. Professor Qin Dahe is the editor-in-chief of the journal. He is also from China Meteorological Administration, and he works in Northwest Institute of Eco-Environment and Resources, Chinese Academy of Sciences. Please, Professor Qin.
Thank you very much, Ms. Convener. And good morning, good afternoon, good evening, good day. I'm very happy to be invited to join this virtual symposium. And also, I want to give the very brief talking about the climate change science and our journal on behalf of the chief editor of this journal. We are frequently talking about the warming. Some people thinking warming is only in the atmosphere. Actually, the warming is in the climate system, which cover the atmosphere, hydrosphere, cryosphere, biosphere, and the lithosphere, linking with the sustainable development. And very new brief, very new message. And the global temperature was increased about very fast. And in the last year, about 1.1 degree above the pre-industry levels. And also the heat wave and the bushfire and make a very a very interesting impact. And in the cryosphere, in the polar regions, in the southern and the north, the polar ice sheet reduced the area very quickly. You see make a lot of interest for the biosphere. And in the ocean, the sea level rising, particularly in the red color region. For example, here is in the West Pacific region, it's very increased 3 times compared with the mean sea level rising. What's the reason? We call the attribution, and very scientific results explanation by this residual forcing. And we say the CO2 provides the largest residual forcing, which make the faster global warming. And the CO2 played a very key message. For example, in year 2008, the CO2 concentration in the atmosphere almost reached to 4.8 ppm V. And what's in the past period CO2 in the atmosphere? We can got the record from ice core. This picture showed the ice core in Vostok Station many years ago, which made the big contribution for the climate change sciences. And this is Vostok Station. I took this picture about 30 years ago, and you see this tower make the breeding program. And this give the great contribution for the Paris Agreement, particularly for the 2 degree and 1 degree limit policies. So we needed to limit the temperature never over 2 degrees until the end of this century, better 1.5 degrees centigrade. And at the moment, during the past 20,000 years, in the atmosphere, at least now 1.1 degree higher pre-industry, and in the past 20,000 years, we never over 1 or 2 degree. And how about in the history? In the synthesis about 1 million years ago, in the polar regions, you see this Antarctica is green. And only 5 million years ago, about 400 millimeter ppm, the Antarctica ice sheet is formed. And it is a very big impact, not only in the nature and also in the society, like the poverty, public health, and food, and the flooding, and the biodiversity. And in the future, by the different scenarios for the heat wave, in the agriculture, flooding, and the water, you see we have the many by the different scenarios, different temperature, we get the different loss. We have to concentrate on the sustainable development for the people, for the local people. Give the case study. This region is in the inland in Russia, and we call the OCEAN system. And the upper city is the cryosphere, and the lower part is desert. In this region, because the climate change, desert want to meet together, and the cryosphere retreat, and this county, and particularly for the OCEAN retreat. This village was very big. Not only about 20 years ago, only 10 people, 3 families, and the situation very serious. We call the Fuchengo village. Last year we visited again. You see, this village only rest of 1 family, only 5 people, including 1 children, who is already moved to the county to the middle school study. So for this region, we have to think about the sustainable development goals under 2030, and we have the design and the good research for this system. It is very there as the simple case. Last time we will brief our general aims to develop the climate system, protect the environment at the heart of the interaction science, and achieve the sustainable development and economic development. And the very big contribution from the teams, particularly for the Ms. Wang Xiaolin and his lady teams, and also some Mr. Shen Yongping and Ms. Miu Qiuqu also can make a good contribution. We have the very good board, and we have our award for the board member, and we welcome you submit a piece of the work writing for publication, because our impacts effect already are almost 2 or 4. Oh, thank you very much. Thank you, Harwood.
Thank you, Professor Qin, for the very insightful talk and for the perfect timing of the talk. Now let's move on to our next talk from Professor Zhaipen Mao. His talk is Advances of Climate Change Science Reflected by IPCC Assessment Reports. Professor Zhai is the co-chair of Working Group 1 for the IPCC 6 assessment reports. He is from Chinese Academy of Meteorological Sciences. Professor Zhai.
Hello, good afternoon, dear colleagues, friends. Taking this opportunity, I would like to present my perspective on advances in climate change science as reflected in IPCC assessments. Firstly, I would like to congratulate for the big achievement of our journal on advances in climate change research. Firstly, you see from this slide, you can see the literature actually since the IPCC established increased exponentially. Yes, also you see IPCC already during the past 3 decades, IPCC has been conducting 6 rounds of assessments, and all those assessments have received are largely based on the rapid increased number of publications, because for IPCC, all the evidence should be from the peer-reviewed literature. So then you can see the publication is so important for IPCC. Now, IPCC has become one of the most, climate change has become one of the most important and quick development science today. When you look at the structure of IPCC reports, look at, since the first assessment report, we can see the development of IPCC, the climate change science, mainly rely on the our understanding in observations, from modeling models, and from the process research. In the first assessment report, however, understanding in these aspects are very weak, and very limited knowledge only from the land surface and from the sea level rise, and based on some simple modeling and theoretical studies. Even for the temperature, we only have some time series from the land surface. We do not have ocean surface yet, temperature yet. And that's the case for the first assessment report. And as for the disciplinary, you can see atmospheric science, marine science, quite weak here, and some link to the ecosystem. Since the second assessment report, the concept of climate system and you'll see detection attribution came into the stage, but also we have very limited knowledge on climate change science. And in the third assessment report, we have reflected more understanding on process and the projections and the expanded visions even to the regional scale. During that time, atmospheric chemistry science became an important discipline contributing to climate change science. In fourth assessment report, observation components in climate system has established, but during that period, you see chapter 4 here, observation, changing snow, ice, and frozen ground. The concept of cryosphere, that the science has not yet explicitly reflected in the outline. But we can see cryosphere science and biogeochemistry science were emerging in IPCC report. In AR5, the climate system components of atmosphere, cryosphere, ocean, along with the biogeochemistry cycle are well covered. Modeling development become more sophisticated. Detection and attribution research come to the regional perspective. Projections covered both in long-term and near-term. Both in AR4 and AR5, Professor Qingda He was the co-chair of Working Group 1 up period. And in AR6, we can see more so integrated to reflect the change in the climate system. You can see climate system reflect in many chapters, but you cannot see one single component of climate system. Also linking to the socio-economic perspective. So here at the bottom, I see it's linked to the anthropogenic activities, socio-economic aspects, and also integrated the long-term and near-term perspective, and more focus on the regional and impact and the risk assessment. What's more, we also have three special report in AR6 from perspective of land, ocean, and the cryosphere. You see the quick development of ocean, the cryosphere, and the echo from the biochemical perspective. So these three areas, we have special reports. The first one is 1.5 degrees C. You see the contents mainly linked to the natural and human systems, also in a context of sustainable development, poverty reduction, and reducing inequality. And for the ocean, the cryosphere special report also have not only a change in the physical system, but also linked to the impacts on the natural and the human systems. And for the land report, and reflect land climate interactions, including biophysical feedbacks, desertification, land degradation, food security, and the terrestrial ecosystem. So from this perspective, you see IPCC, even from Working Group 1 perspective, strongly linked, more and more close link to the human and human system, linking to the socio-economic perspective. In conclusion, we can see that this figure I borrowed from the AR5. You see the development of the observation system. At the beginning, we only have capability to observe the surface temperature, pressure, and then we have more from the atmosphere and the satellite. Over the past decades, new observation system, especially from the remote-based systems, have increased the number of observation of the Earth's climate by order of magnitude. For this figure, you see many time series here. Mainly, you see try to reflect the change in the climate system from the multi-line evidences. Several time series reflect from the atmosphere, and then from the ocean, and three, from the perspective of the cryosphere change. So through these multi-line evidences that to reflect the change in the climate system, as Professor Da He Qing mentioned previous. From model development perspective, we can see, at the early beginning, we only have some knowledge on atmosphere, land, ocean interaction, and then increase to the aerosol, carbon cycle, vegetation, atmospheric chemistry, and then to cryosphere. So you see the development of the climate system modeling. And in AR6, even linked to the shared socioeconomic pathways, because socioeconomic development can link to the radiative forcing, and then you can see build more closer link to the working group 1. And also, I try to draw a figure of the, for different discipline development during the IPCC assessment period. You can see that not only atmospheric sciences, but also marine sciences, biogeochemical sciences, atmospheric chemistry, cryosphere sciences, hydrological sciences, and the social economic sciences have been developed during the process. Here also you can see that based on the observation, the confidence in model, process-based understanding, and more sophisticated modeling. And we built multi-line evidences. At the 1990, we only have very limited knowledge, say, gave a broader overview of climate change science, discussion of uncertainty and evidence of warming. So very weak, and try to link to the warming, even do not know how much warmed. And then when look at the AR5, here's a human influence on the climate system is clear. So something reflected in 2018, human activity estimated to have caused approximately 1 degree of warming, of global warming. You see, even we have quantitative description of the human influence on the climate system. So in conclusion, say throughout the IPCC assessment period, we can see the concept of climate system change has been well established. Also during the same period, atmospheric science and all other science disciplines has rapidly developed. Linkage to the socio-economic aspects become more and more closer. And we have great opportunities to contribute to the development of climate change science and to support the decision-making process. Thank you all for the attention.
Thank you, Professor Zhai, for the informative and the brief sharing from IPCC reports. Now let's welcome Professor Qi Ye. Professor Qi is the Associate Editor-in-Chief of our journal. He works in Hong Kong University of Science and Technology. He also holds a position in Tsinghua University. Professor Qi's talk is, can China's energy policy deliver Paris commitments? Or is policy-driven peak and the reduction of China's carbon emissions? Okay, welcome, Professor Qi.
Okay, thank you, Chungfang. Hello, everyone. So I want to thank Professor Qin Dahe, the Editor-in-Chief, for this opportunity to present this work we recently had the honor to publish on the Journal of Advances in Climate Change Research. And the title of this paper is Policy-Driven Peak and Reduction of China's Carbon Emissions. And this is a work done by an effort with my co-authors, including Lord Nick Stern, Professor He Jiankun, and Sir David King, and some of my colleagues, Tianle Jiaqi, and Wu Tong. And so 4.5 years ago, China made the commitment, the nationally determined contribution under the Paris Agreement. So there are two elements in there. Number one, CO2 emissions will peak around 2030, okay, plus minus, and to make the best efforts to peak early. Element two is the share of non-fossil fuel in the primary energy consumption to be around 20% of 2030. So these are the commitments. Then this is the China's energy-related carbon emissions. As you can see, the year 2015, when the commitment was made, was actually decreased, slower than 2014. It keep growing Until 2017, there is a little bit increase, 2018, a little bit increase. So it makes you to wonder when the carbon peak will come. So that would be the number one question we're trying to answer under this study, all right? Then another very important effort by China, the Chinese government, only a few months after the Paris conference, China released the National Energy Policy, National Strategy for Energy Production and Consumption Revolution, 2016 to 2030. Now, there are a number of targets. 3 of them are of particular importance for this study. Number 1, China is to cap the overall energy consumption by 2030. How much is it? 6 billion tons total, right? Coal equivalent. Number 2 is just about the same as the China's NDC under the Paris Agreement, 20% of non-fossil share, right? No new target. Number 3 is interesting, is a non-fossil fuel based power plants represent half of the overall capacity, right? Just thinking about the energy consumption on power generation is just about half, right? That just gives you 25% of the non-fossil fuel share by 2030. So this is slightly different than the 20% target. So this is also represent a stringent policy goal for China's energy policy. So our question number 2 would be, would these national energy targets deliver the nationally determined contributions under the Paris Agreement, all right? So one is the international policy on climate change, and the other one is the domestic energy policy. Are they consistent? To answer this question, so basically, we need to project the carbon emissions into the future. These would be something we normally see in projecting the carbon emissions into the future. And the conventional approach to this is the Kaya decomposition. We all know this pretty well, right? So we basically decompose the carbon emissions into 4 different terms: population, per capita GDP, energy intensity, and carbon intensity, and that gives you the total carbon emissions. But the thing is, we don't really need all those variables or data, right? And plus, all these data have tremendous uncertainties. So we only need to look at the lower 2 rows. Over here is, we can actually calculate the carbon emission based on the carbon intensity if we have them, and also based on the energy consumptions. So that national policy specified 6 billion tons for energy consumption. It's also specified the share of non-fossil fuel that is actually produces the carbon intensity. There is a one-to-one correspondence between that share and the carbon intensity. If you have them, you don't really need all other data. So so we take an extremely simple approach to answer the 2 questions over there, all right? So we don't really have the carbon intensity, but we have this non-fossil fuel share. That's why you can basically replace that variable over there. Okay, still we can set scenarios. The scenarios, that's 6 billion tons. 6 billion tons, that's the national target, the national policy. We also use a 5.5 billion tons. Why? Because this is something that the expert will anticipate. 5.5. What they say, the best expert, they keep saying there is no way we can get to 6 billion tons by 2030. All right. So they will think 5.5 billion tons will be the maximum. So that's why we take that one. So we tried 20% from NDC. We also tried this 25% elicited from this national policy. So basically you can have these 2x2 combinations for setting the scenarios. All right, the rest of this is pretty straightforward. All right, we have a historical carbon intensity. You can calculate from that energy mix. And excuse me, this is the wrong title. This should be the total energy consumption. All right, then we have a historical. Then we can predict into the future. So we have 5.5, 6 gigatons, and also we have a trend extrapolate from 2012 in here. We can also, oh, this is terrible. This is we can also calculate the carbon intensity. This is actually the carbon intensity. Doing the same thing, right? You have a historical, then you have certain scenarios, 20%, 25%, and trend 30%, 35%. We can do this pretty easily. Now, based on these projections, you can, and also these combinations, you can have this table. All right. The first row here under NDC here is we take the 20% share non-fossil fuel, right? We can try 5.5 billion tons of total energy, or 6 billion tons, or we can try the trend extrapolation. So the point is, none of these scenarios will give you a carbon peak earlier than 2030, right? So we have this 2043, the year of 2043, if we can achieve 5.5 billion tons total energy consumption. You can do 2050, you know, after the middle of the century, if you go with a 6 billion tons of total energy consumption. Well, the point is, if you go with the NDC with a 20% share for non-fossil fuel, there is no way you can actually achieve the carbon emission peak by around 2030, right? So basically you can say that two targets are internally inconsistent, right? Now, what about the strengthened target with a 25% of non-fossil fuel? Well, that is specified under the national strategy, all right? If we go with 5.5 billion tons of total energy consumption, then we can achieve the peak by 2024, and after that we see a decline of carbon emissions, energy-related carbon emissions after 2024. Okay, if we go with a 6 billion tons of total energy consumption, we cannot achieve the carbon peak until 2033. Well, you may argue that is around 2030, right? So basically, you can see if we follow the national strategy, you know, with a 6 billion tons of total energy consumption, with a 25%, which is an enhanced target for the energy structure, energy mix. It's still pretty hard to deliver the 2030 peak. Ironically, if we just extrapolate the trend for our total energy consumption, or the trend for the carbon intensity, then we can achieve 2030 with no problem, right? Then that is quite ironic. So basically, we can just keep going. We can keep going. We can achieve the 2030. So I want to note that this study was completed before the coronavirus crisis. You know, with this coronavirus, we can be even more sure that extrapolating the trend will surely get a earlier carbon peak. So the interesting thing is, as we have seen earlier, that after 2014 we see ups and downs, and with minor changes. You can safely say 2014 was probably the year when the China's carbon emissions are already plateaued, right? So that will last for a while, maybe for 10 years. And after the 2024, then we can really get a decrease the carbon emission based on the policy and also based on the trend that we have seen so far. All right, then what about even more stringent targets? As many of us have seen in the last couple of years, we have pressures to push for earlier peak. Well, some of our colleagues have presented 2020, 2025, even 2030 peaks. And one interesting thing you can see is many of them are actually use 5 billion tons of total total energy consumption. So last year it was a 4.9. So 5 billion tons probably will not be able to keep until to the 2030. Now we actually derived a model to show this in a even more simple way. So what we can see this line over here. Well, this is something we call the peaking possibility curve. So any policy be above this curve will bring us an earlier peak. Okay, anything below this curve, like the basic policy we have seen, and will not be able to maintain the 2030 peak. So as we can see, the basic policy, no way, all right? What about this stringent policy? Stringent policy is if we can go with the, we can go with 5.5, great. 6 billion tons, it's very hard to bring us the 2030 peak. So what about we have a even stronger policy with a 30% of non-fossil fuel share, and also with a 5 billion tons of total energy consumption. So that is a climate aspiration that will far enough to fulfill the carbon peak. That will bring us a much earlier peak. So with this tool, we can actually try several different policy scenarios as we presented in the paper. So basically, that is our conclusion. Our conclusion is the basic policy will not be able to bring us the peak by 2030, but the enhanced policy, enhanced the non-fossil fuel share will be able to bring us the peak. But the thing is, in the same time, we also need to keep our total energy consumption below 6 billion tons by 2030. Thank you very much.
Thank you, Professor Qi, for talking us through the China's energy policy and the very detailed scenario analysis. Next, let's welcome Professor Bi Peng. His talk is Climate Change and the Population Health in China. Professor Bi Peng is from School of Public Health, University of Adelaide, Australia. He's also the director of Australian National Climate Change Adaptation Research Facility, Vulnerable Community Network. Welcome, Professor Bi.
Well, thank you very much. Thank you for the opportunity to talk to you. And I'm talking on behalf of my courses, Professor Shi Xiaoming and Professor Liu Qing from China CDC. So the topic for my talk today is climate change and population health research in China. So I'm try to identify the current knowledge and further directions. So as you can see, the impact of climate change on human health has been quite negative. It's because of the increase in temperature, because of the significant weather event, and because of the sea level increase, it will affect the change in the ecology of the vector an increase of a lot of allergic diseases and waterborne diseases, malnutrition, diarrhea diseases, and heat waves and its related diseases. So for the past 10 to 15 years, so using the disease surveillance data, so a lot of researchers from China and their collaborators have been targeted for the infectious diseases and non-infectious diseases. So for the infectious diseases, we targeted for dengue fever, malaria, Japanese encephalitis, and trichomoniasis. So these all vector-borne diseases and including hand-and-mouth infections. And also for a lot of foodborne diseases, such as rotavirus infections, hand, foot, mouth diseases, and diarrhea. And this research shows the increase of temperature and changing pattern of the rainfall will bring about more infectious diseases. So these are quite important findings because the research findings have been provided to the local health authorities for the design of effective intervention strategies and early warning system. So for example, in Guangzhou, in southern China, each year, local councils ask local residents to clear up their gutters and try to reduce the density of the mosquitoes to reduce a possible dengue fever outbreak. For the non-communicable diseases, mainly use mortality as health indicators, researchers have identified the positive associations between temperature and cardiovascular diseases, mental health issues, and renal diseases, especially in very hot days. And there have been very limited studies targeting for the outdoor workers, which we believe they are also at high risk. So these studies we call health risk assessment have helped us to identify a lot of vulnerable populations. For example, the elderly, the infants and children, and people with chronic diseases, which most of them are still take medications, and outdoor workers. So this suggests us the most vulnerable population for the health intervention. And also working closely with China CDC and a lot of university researchers, and they're targeting for what about our current healthcare capacity and capability to deal with such challenges. So for example, in the extreme weather events, do we have enough doctors and nurses in the emergency department visits, in the hospital admissions? So there are some studies undertaken right now. So obviously there are some knowledge gaps. For example, for the non-communicable diseases, most health indicators we use still mortalities rather than morbidities. In the past 2 to 3 years, there are several large grants using morbidities like hospital admissions, emergency department visits, and ambulance calls out as health indicators to see their associations with climate variability and climate change, so which is good. Another knowledge gap could be, say, the development of diseases may be due to a lot of factors. So climate variability only part of them. So what proportion of the contribution coming from climate variability and climate change? So that is another knowledge gap which should be addressed in future. And the third one is the burden of disease. So internationally, we have global burden of disease studies, but so far, so climate change has not been listed as a risk factors, which should be addressed in future. And the increase of the mortality and the morbidity normally costs a lot of money to the families and to our healthcare facilities. So what are the healthcare costs due to climate change in China? For the outdoor workers, so what are the productivity loss due to climate change? So these are the knowledge gaps still need to be addressed in future. And another important issue is health adaptation research. So in terms of the further research directions in the climate change and health area. So I think we should address two issues. One is mitigation, another one is adaptation. So in mitigation studies, for example, so we drive a car to work every day. So on the one hand, we produce emission greenhouse gases to the atmosphere. So if I do not drive a car, on the one hand, I reduce emission of greenhouse gases. On the other hand, if I ride a bike or if I walk to work, I can have my physical exercise. So that's two benefits. So we could use different scenarios, mitigation scenarios, to say active transportation and what's their impact to our climate and what's the impact to our health benefits. Another research direction I think we should identify is most vulnerable population identifications and their protection mechanism. For example, we say the elderly, most of them with chronic diseases. How can we protect them? How can we send a clear message, health message to them? Say, most of the people, we have smartphones, but it's not applied to a lot of elderly population. So in the very hot days, how do we send an effective heat and health message to them? For the outdoor workers, like road workers, construction workers, and more importantly, emergency response workers during the hot days, how can we protect them? Another issue we could focus is our current healthcare workforce capacity building and our health emergency preparedness. So for example, in the very hot days, do we have enough doctors and nurses in the emergency department? Do we have sufficient ambulance to be ready? And do we need to have a resource relocation to them? And in terms of policy and guideline development, say, do we have a local specific practical guidelines for our local hospital, for our local emergency department? And can we identify that? And then most important, if we introduce our local guidelines, how do we have intervention evaluations? And another thing I would emphasize is risk communications and community health education. So what is the effective way for us to convert the effective heat and health or extreme weather and health message to our community is quite an important issue. So internet is quite popular. As I mentioned before, not everyone is using internet, not everyone has a smartphone. So we have to look after these people who are disadvantaged. So the policy, in terms of the policy, and I understand in the several cities in China, such as in Chongqing, in Shenzhen, in Nanjing, we have set up the heat and health early warning system already. And what about their evaluation? For the regional China, do we have threshold temperature detection for them to protect the people health in the rural and remote areas? And do we have a national climate change adaptation and health research strategies and directions? And more importantly, we need to work closely with community to get the community engagement so their health and well-being could be protected. Thank you. That's my talk. Thank you.
Thank you, Professor B, for pointing the further directions of socio-economic development and policy making to protect population health from climate change. Next one, let's welcome Professor Jin Huijun. He is one of the editors of our journal. He's from Northwest Institute of Eco-Environment and Resources, Chinese Academy of Sciences. Professor Jin's talk is impacts of Professor Jin's talk is impacts of permafrost degradation on vegetation. Professor Jin, please.
Thank you. My name is Huijun Jin, and I'm from State K Laboratory of Frozen Soil Engineering. I choose this topic because this is recently a very hot debate on what the permafrost degradation would be impacting the ecosystem. Here we are more focusing on the change of permafrost degradation as induced by the climate change, especially the climate warming. Oh, sorry, it's not yet. Okay, first, I think it's necessary to define what is a permafrost. This is a very special term that defined as the ground that remains an ant or below 0 degrees C for at least 2 consecutive years. Where are the permafrost? We can see about 1/4 of the exposed Earth's surface, especially in the northern hemisphere, is underlain by permafrost. Most of the permafrost are located in Arctic regions. We also have some alpine and high plateau permafrost at very high elevations in Central Asia and some other countries. Vegetation on the Qinghai-Tibet Plateau is a very unique environment because very large elevations in mid latitudes. We can see most of these areas have some kind of vegetation like alpine meadows, alpine steppes, and alpine deserts. We have heard a lot about the permafrost degradation. Everybody can talk about something about the permafrost degradation. Of course, during the past 60 years, permafrost has been warming and degrading extensively on the globe, especially according to the latest surveys by Dr. Biscarbon in 2019. As a result, the permafrost degradation has been altering the environment for the ecosystem has been developing. You can see there are a lot of areas that used to be forest is now replaced by some kind of sages vegetation or wetlands. Then if we want to talk more about the permafrost and its degradation and its subsequent impacts on the ecosystem, we would like to talk a little bit on the permafrost degradation. Generally, you can divide the permafrost into several different stages of degradation. First, you can see the permafrost or the ground is warming up. Then at a certain time, the permafrost table will be deep enough. It will be some kind of talc, which is unfrozen zone all the year round developed on the top of the permafrost. Then in about a few decades or to a century time level, the thaw of near surface permafrost would occur. What we are more interested in the thawing of the near surface permafrost because that's the most closely related to the ecosystem. This can also be viewed from the spatial distribution permafrost. To the very north, you can see the permafrost is more continuous and the permafrost temperature is very cold, say from -12 to about -5. Then if you move from north to the southward, you see permafrost become more discretized or dispersed. Then eventually you will not see permafrost and permafrost will convert into the seasonally frozen ground. Of course, if you look at the permafrost temperature profile, you can see either your permafrost will be degrading top down or from bottom up or expand laterally. Of course, in most situations, you will see that permafrost has been degrading or thawing at all directions, which have been all observed in the field. So all these kind of different scenarios and combinations will be depending on the ground ice content, ground temperature, and regional climate patterns. Well, we have a cartoon here to illustrate what could the permafrost degradation impact on the vegetation. Permafrost degradation would or could induce primary or secondary successions, and further on the change on species composition, vegetative cover, species diversity, and others. At a certain time, there could be some kind of retrogressive slow slumps, which will increase the exposure of the bare ground, and then the higher richness of plant species during vegetation successions. But if you have a certain situation like warming and drying climate, then your active layer will go down and your water table might drop. That eventually will result in the vegetation cover declines. As we already have observed in the sources area of the three rivers like Yellow, Yangtze River, and others, vegetation has been degrading quite extensively. This is also because of the hotspot. People are doing the research on that. Then this illustrates more like the situation C on the upland. Thickening active layer leads to shifts in vegetation types from alpine meadows to alpine steppes. Sometimes even go to the alpine deserts. We are afraid of this kind of situation because in some headwater areas like the Yellow River, if the permafrost continue to degrade at a certain point, the Yellow River sources may be closed into an inland basin and will not give water at all. This is a very dire situation because that source area give about 1/3 of the total discharge of the Yellow River. Then at another end, situation A, in the Arctic lowlands or intermountain lowlands, permafrost degradation also may result in a very extensive degradation of summer-cast lakes and shifts from terrestrial forest to wetlands. During this process, you can have some kind of like a drunk forest developing. Well, most of the situation we see in the field is the slope situation. You have certain slopes, either it's very gentle or very steep. Soil slope might develop on the bare ground. And the bare ground first will be invaded by some pioneering species like graminoids. So this diagram basically shows most of the cases that could be described in the real world. Well, of course, the permafrost degradation may not directly impact the vegetation. All this impact could be going through the changing soil hydrology and the nutrient, such as because lowering active layer and the permafrost table, then groundwater table will slowly drop down and the soil moves downwards with permafrost table. Then the soil water availability to plants will become more and more difficult. And some kind of vegetation may adapt to this environment, but others may not. So permafrost degradation may dry the upland soils and wet the low soil. So we divide it into 3 different situations. In the meantime, on some of the gentle slopes, you may have some enhanced recharge situations. Of course, we can say, okay, the drier will be drier and the wetter will be wetter. But eventually, after 1 century or 2 centuries, for example, in Arctic slope or Arctic tundra area, eventually because the permafrost will goes down much deeper, so the surface water will be much drier, and then it can result in a better drainage situation. Another way that the permafrost degradation would impact the vegetation is going through the nutrient cycling. Studies have shown that in comparison with the inactive layer, there are more than 40 folds more nitrogen stored in permafrost soils. And of course, permafrost soil may release the nutrients formerly frozen in the permafrost. And permafrost degradation and the warming soils increase the nitrogen availability in the near surface soils. And also a lot of field studies and the incubation studies also show that organic matters decompose much faster at the depth than if you compare it to the topsoils. So with degrading vegetation, total nutrient contents may decline remarkably. So to conclude my presentation here, with a diagram here. So first, we try to identify the close relationships between the vegetation and degrading permafrost. We can see all kinds of different symbols of plus or minus. It's evident that we can say the vegetation processes are closely coupled with the soil hydrology and the soil nutrient regimes. In warmer and wetter soils in lowlands, inducing vegetation from shrublands or changing into the graminoids, in other words, like sages. But in warmer and drier soils on the upland, like we already said on the Qinghai Tibet Plateau, it might change from the moss to graminoids to shrublands or forests. Secondly, the change in soil hydrology and the soil temperature improves or reduces soil nutrient availability by different kinds of microorganisms, resulting either cellular or deeper rooted vegetation. This has been observed in a lot of places, either in the Arctic or on the Qinghai Tibet Plateau. For example, some of the Arctic tundra has been replaced by more deep-rooted shrubs or even forests. On the other hand, change in soil hydrology also have degraded most of many important grassland on the Qinghai Tibet Plateau. However, there are a lot of priorities and unanswered questions on this fledgling field. In a word, we are very much at the fledgling stage of doing this kind of research. And this review that will be published on the ACCR give a brief overview of what happened on this field during the past 10 years. My presentation is finished. Thank you very much.
Thank you, Professor Jin, for speaking out the warning of the negative impact on vegetation from permafrost degradation. Before we move on to next talk, may I kindly remind that we are a little bit late. So for the next two speakers, please kindly stick to the time frame. Thank you very much. Now, the next talk is from Professor Fang Yiping. His talk is From Cascading Impacts to Cascading Adaptation, Enhancing Livelihood Resilience. Professor Fang is from Institute of Mountain Hazards and the Environment, Chinese Academy of Sciences, University of Chinese Academy of Sciences. Please, Professor Fang, thank you.
Okay, very happy and honored to have this opportunity to share research experience with anyone. So since Editor-in-Chief Qin and since Editor-in-Chief Wang, and also thanks Wang Congfang, thanks much. So my presentation topic is from cascading impact to cascading adaptation, enhance livelihood resilience. So I want to briefly introduce my presentation framework, cascading impact of climate change and adaptation transformation. and how to establish the model of cascading adaptation. Next one is I want to introduce a model application. My research target and objective focus on the livelihood, and the case size is core sea level basin. You know, livelihood is a means of make a living. So I think it's easy to understand. It covers 5 different capitals: nature capital, human capital, and physical capital, financial capital, and social capital. I think 5 capital is important. You know, cascading impact of climate change on livelihood are the dynamics and the multi-level presence of direct or indirect effects of climate change on livelihood system. So these impacts include livelihood capitals, livelihood behaviors, and also include livelihood strategies and livelihood outcomes. So it's a different order. I think it's very complicated and it's very comprehensive. So it's a cascading impact of climate change on livelihood. You know, in order to enhance resilience livelihood and improve of efficiency of application, so I think it's very, very important to emphasize logical transformation from cascading impact to cascading adaptation. So I think it's very, very important promote logical transformation from cascading impact to cascading adaptation. What's a cascading adaptation? According to my understanding, I think is comprehensive and effective network of adaptation strategies with following important 4 latches, means Lakika feature, massive feature, and the regional feature, and the dynamic feature. I think it's very important for features, I think. Okay, because impact of climate change target as cascades across environment and the human system. So adaptation of climate change also responds as cascades across environment and the human system. I think it's really important. So it's the key towards modeling cascading adaptation according to corporal environment and the human system. So these figures show 3-dimensioned model. So I think it's basically a model, an important model. Okay, the core component of cascading model is the plan projection seeds model. I mean from 3D to 2D model. So in these city models, S means structural dimension, focus on the objectives. Here is livelihood. And I means issue dimension, focus on the problem and the challenge of livelihood. T stands for a time dimension, focus on the process and the dynamic. So it's a change. And the S means space dimension, focus on the scale. For example, regional scale, community scale, and also individual scale. So it's a very different scale. So this SAYS model covered 4 important elements. You know, core sea level basin, short among China, Nepal, and India, is one of the important transboundary level basins in the Hindu-Kushi Himalaya region. So core sea level is very important transboundary level basins in this area. So core sea level basin have a huge attitude, a job happened from the top to bottom. More than 4,000 meters elevation difference from Qinghai Xizang plateau to plain. So it's a big change, altitude and elevation difference. So it's an important case, I think. And critical livelihood changes in the core sea level basin cover the nature hazards, food insecurity, poverty, water scarcity, and landslides, and especially gender inequality and cascading risk because of many different elevation change and the different geological conditions and the ecosystems. So very big change and significant change in this area. So based on size model, so I try to use this size model. Application number 1, cascading adaptation, to try to emphasize natural disasters, especially drought, flood, and geological disasters. So these figures shows 3 different strategies clusters of drought control and prevention, flood control and prevention, and geological disaster control and prevention. There were different strategies clusters. So I think is application number 1. Application number 2 is cascading adaptation to emphasize political capitals. I mean livelihood capitals, especially water and food, because in this area, water scarcity and food insecurity is very, very common in this area. So these figures show how to mitigate water scarcity and how to mitigate food insecurity. So this figure shows 2 different strategies clusters to elevate water scarcity, to elevate food insecurity. So I have different strategies and different order according to S, I, T, and S. So, and application number 3, try to emphasize social equality, especially land equality and gender equality. So this figure shows 2 different strategies cluster of land system. Try to improve land reform and land system. And the second strategies cluster of gender inclusion, gender equality, how to improve. So it's a very important strategies clusters. And last one, application number 4 is cascading adaptation to try to emphasize transboundary cooperation, include upstream, midstream, and downstream. It's also China, India, and Nepal try to cooperation adaptation of climate change. So this table shows a very important strategies cluster of transboundary level based cooperation. So according to size model, try to improve a logical transformation from cascading impact of climate change to adaptation of climate change. So I think it's important, and I think it's improved resilience of livelihood. I think is a very significant models. So okay, this end of my presentation. Thank you for your attention. Thank you very much.
Thank you, Professor Huang, for the very comprehensive model of enhancing the livelihood resilience. Now here comes our last talk from Professor Liu Yonggang. Professor Liu is from Department of Atmospheric and Oceanic Sciences, School of Physics, Peking University. Professor Liu's talk is future sea level rise along China coast under 1.5 to 2.0 degrees Celsius global warmings. Professor Liu, please.
Receive a message. Okay. So why do we care about 1.5 degree and 2.0 degrees? Because if global warming is larger than 2.0 degrees, many of the tipping points of the Earth system will be crossed, and it will be very disastrous to the Earth's environment. And then later, people thought that it would be much safer to limit global warming to 1.5 degrees. This is the Paris Agreement in 2015. So why do we care about sea level rise? So if you look at this map, like the Guangzhou city will be affected. Some parts of its coast will be underwater if sea level rises by like 1 to 2 meters. And the Shanghai area is much worse. If sea level rise is by about 2.5 meters, about a third of the region will be underwater. So you might think that 2.5 meters is a large number, which is hard to reach. Then you probably haven't heard about the flooding due to sea level rise. This map shows the sea level rise. It's due to storms or high tides. It happens maybe like once every 10 years. And this flooding, it has very high water. It's about 1 meter higher than the local sea level. So if your local sea level rises by about 0.5 meter or 1 meter, then during the extreme events, you will have a 2 meter or 2.5 meter sea level rise locally. And this kind of flooding events are very costly to the world. So this graph shows the annual flooding cost due to sea level rise. So for the 1.5 degree warming threshold, the annual flooding cost will be this is the one, but the unit is $10 trillion per year. So at 0.5 meter of sea level rise, the global flooding cost will be $10 trillion per year. And a small increasement of global warming to 2 degrees Celsius will be another significant increase of this flooding cost. So flooding sea level rise is a very serious problem to the coastal economy and societies. During the past 25 years, we have satellite altimetry observations. You can see from here, during the first half of this 25-year period, China experienced a faster sea level rise than other regions, other coastal regions in the world. But in the second half, it is not so fast anymore. Many other regions has a much higher sea level rise rate. the global mean sea level rise trend is about 3.1 millimeter per year during this whole period. That means even if the sea level rise is steady, then we will have a 31 centimeter sea level rise at the end of this century. That's just the sea level rise of the ocean. If you look at the coast region itself, so we have many tide gauge stations in this region, which have a longer data records, which can tell us how much sea level rose we got during the past few decades. As you can see from this table, at some locations like this one, it has a much faster rate of sea level rise than the global mean. And at other locations, it has a much smaller rate of sea level rise. So that means the land itself is sinking or rising, which causes a much different local sea level rise than the global mean. So in order to project the future sea level rise, you have to consider the vertical land motion. Vertical land motion could be due to tectonic movement, sand compaction, or underground water extraction. So how to project this future sea level rise? So we need model data. So we need climate model data. We use simplified models to do these calculations. So there are many components contributed to the total sea level rise. So for example, the ocean expands due to thermal expansion. And it also rises locally due to its dynamics. And it also changes due to glaciers melting, ice sheet melting, and the land water storage change. And there's also another component which is called glacial isostatic adjustment, which I will introduce momentarily. So if you calculate the sea level rise caused by all these components and combine them together, then you take into consideration the local land motion, you will get a sea level rise locally for the future. So next I'm going to introduce about the glacial isostatic adjustment. For example, if you have a mass loss from a Greenland ice sheet, it's located here. The mass loss is equivalent to a global mean increase of sea level by 1 meter. But because this mass change will induce deformation of the solid Earth and also induce change of gravitational force or gravitational field, you get a very non-uniform sea level rise over the globe. And this pattern of sea level rise is called fingerprint specific to this kind of mass loss. So this, on the right is a different fingerprint for the mass loss from West Antarctic ice sheet. This fingerprint is quite stable for a few hundred years, but on longer time scale, like 1,000 years later, the sea level rise pattern will change. It's much smoother. And after 4,000 years, it's even smoother. So because about 21,000 years ago, there were two very large ice sheets sitting on North America and Northern Europe. These started to melt about 19,000 years ago and completed about 7,000 years ago. And their influence continues to today. This on the right, it's a very good example of sea level change locally, even without global warming. So this is due to ice sheet change many thousands of years ago. The local land is continuously rise during the past 10,000 years and is still going on. So this is called the glacial isostatic adjustment, which is a signal we must take into consideration when projecting future sea level rise. So by the approach I introduced before, then we calculate how much sea level rise we will get due to global warming. Global warming of 1.5 degrees Celsius and 2 degrees Celsius. So if you look at the numbers under this 50% probabilities, you see a sea level rise, which is around 45 centimeters at 2100 years. And if it's 2 degrees warming, then you get about 50 centimeters. These numbers are quite close to each other. It's quite smooth. Some of them are slightly larger. But this is before we take into consideration of the local land motion. So if you look at the spatial pattern, it looks like this. The Bohai Sea and the Yellow Sea here experiences a smaller sea level rise due to global warming. I will skip the other figure for the time reason. And for all these tide gauge stations, so we had about 18 stations. If you look at the sea level rise at this station, it has many components. Like this origin one is due to thermal expansion of the ocean, and this gray bar is due to mountain glacier melting, and this yellow bar is due to melting of Greenland ice sheet, and this blue bar here is due to the melting of Antarctic ice sheet. As you can see, the largest contributor to the sea level rise for the next about 100 years is thermal expansion of ocean. It's the same for the 2 degree warming too. And the second largest is melting of mountain glaciers. Again, it's quite smooth. All the stations experience similar sea level rises at the end of the century. But if you consider the local land motion, so this is the local land motion we have calculated by subtracting the altimetry track record and the tide gauge record, and further subtracting the glacial isostatic adjustment signal. And you found that on this station, Lucy Station, for example, Lucy Station is here. It's close to Shanghai. It's sinking very quickly. So this positive number means it's sinking. It will cause a future sea level rise, extra sea level rise. So it's sinking at a rate about 3 millimeter per year. And other stations also experience some sinking, and some other stations, they are rising. So if you consider this signal into the regional sea level projections, you will find that the sea level projection for the end of the century, it's much rougher. So some stations experience much higher sea level rise because of the local land motion. And some of them experience a less sea level rise because of the local upward land motion. So I think I will stop my talk here. There are a few conclusions which I will not read them anymore. Thank you.
Thank you, Professor Liu, for talking us through the risks of sea level rise. That is the end of all the academic lectures. Thank you again to all the speakers for the insightful talks. We hope that this will point to the directions of future research in the relevant fields. Most importantly, we hope every one of us will learn and reflect what we can do to curtail climate change in our daily behavior. Now, because we are running late, so we will directly move on to the next panel discussion session. It is the discussion on how to get published in advances of climate change research. We have prepared a list of questions for our guest speakers to talk about the journal, to share their experience and advice on how to get published in the journal. But in the meantime, everyone will be able to pose your questions using the function, the Q&A functionality at the end of your Zoom screen. So I will then forward as many questions as possible to our guest speakers. We have 4 guests to attend this panel discussion. 2 of them are from our author representatives. Dr. Luo Dongliang from Northwest Institute of Eco-Environment and Resources, Chinese Academy of Sciences, and Dr. You Qinglong from Institute of Atmospheric Sciences, Fudan University. We also have the executive editor, Dr. Wang Xiaoling, as well as the publisher of the journal, Ms. Jia Dewei. So Ryan and Shouyang, could you please just play the slides about, about this symposium? Okay, now let's move on because we haven't seen many questions yet. So I will start the discussion by asking Dr. Luo and Dr. Yu first. Dr. Luo, first of all, could you please let us know when was your last paper published in ACCR and what was your publishing experience in general?
First of all, I'd want to thank you for giving me a chance to communicate with the petition authors to ACCRE. My last paper was published in our Journal of Advancing Climate Change Research. It's about to study the variations of alphanicals in the headwater area of the Yan River, Tibetan Plateau, using Google Earth Engine. This paper was published at the first issue of 2020 in Advancing Climate Change Research. Advancing Climate Change Research. That's all. Thank you.
Thank you, Dr. Luo. And Dr. Liu, Dr. You Qing, Dr. Yu, may I also ask you to share your experience of publishing with ACCR? When was your last paper published?
Okay, so this is a very long story because I also published my last paper, also the first paper in Advance in Climate Change Research. I think it's about 5 years ago, maybe. So that paper is about the climate change over the Tibetan Plateau, based on the recent observational data and also the reanalysis data, and also the climate models data. I also used the seismic fire models to perform the climate change over the Tibetan Plateau. So and also get a certification from the journal that my paper had been highly cited in past 4 years. I think it has been cited by 50 times. So it was also the several top cited papers. So it's also my pleasure. So for my future planning, I also want to submit my paper to this journal because I think it's deserved to show my recent result to this journal, and it's also a very is becoming more and more top journal or international journals in the coming ways. Thank you.
Thank you for the great sharing. It seems both of you have a pleasant publishing experience with ACCR. Before I move on to the next question, everyone, you can see now on the screen, we have a WeChat code. That is the WeChat group about this activity, about our journal. So everyone can scan the code to join the group. We will be sharing the some of the presentations and the recording of the symposium to the WeChat group, and everyone is also encouraged to share your research in this group. Thank you. Okay, now I can see a question in the Q&A session. It says that to what extent would ACCR consider publishing social science research related to climate policy and governance? I think this is for Dr. Wang Xiaoling, the executive editor.
Yeah, thank you. Thank you for the question. Yes, we have already published articles on climate policy and governance. Welcome to the submission.
Mm-hmm. Okay, that's good to know. So Dr. Wang, may I ask you that after the journal gets the first impact factor, have you seen any differences in the quality and the quantity of submissions to the journal?
Yes. After the first impact factor has released, yes, we have got more submissions than before, and the qualities, especially articles from China, yeah, the quality have been improved. Yeah.
Great, that's really great to know. Dewey, here is your question. Now,
yeah.
Our editor and our authors have shared their experience of publishing or how to get published in the journal. So as the publisher, I know you have been monitoring the journal performance. So could you please share some basic data about the journal so that our authors will know, if it's possible to submit to the journal, like the acceptance rate and the editorial speed?
Yes, sure. So till now, based on the data in last 2 years, the acceptance rate of ACCR is around 25%. The immediate rejection rate, that is the rejection without peer review, is around 65%. Yeah,
it's a very, please go ahead. Please go ahead.
Which is quite a decent, quite a media average among the scientific journals.
Okay, thank you. Now, next question, let's firstly ask Dr. Wang Xiaoling. After the journal gets the first impact factor, you have seen the increase in the number of submissions. So do you find it more difficult to invite peer reviewers? So if so, would you encourage young researchers to conduct peer review for ACCR?
No, it's not very difficult. There is not very difficulties to find reviewers because there are so many new submissions on the just on the new advances or new research. So in the articles are interesting. So the reviewers are very happy to review the articles, and I encourage the young scientists to enjoy in the review.
Thanks for sharing this. I have to say, that's very lucky of you that you have no difficulty in finding reviewers, peer reviewers.
Yeah.
Let me ask the two authors, Dr. Yu and Dr. Luo. I know you have published with ACCR successfully, but if you have received an invitation to do the peer review for the journal, would you be happy to do that? And do you need any support to do the peer review from the editor or from the publisher?
Okay, it's my pleasure to have a chance to read the research papers from the advanced in climate change research. So I think the platform for the submission is very useful. So we can easily to review the draft from the authors and to write our comments in the system. So for my side, there's no it's very easier to download the paper and submit my comments. Okay, thank you.
Thank you. Dr. Luo, do you have any input on this?
Yes. Until now, I do not review paper in ACCRE, but I hope I could have a chance to review the papers in the future. I will be as a review. I will try my best to be objective and fair when reviewing manuscripts, and I will pay particular attention to the sections of abstracts and discussions and conclusions, and especially to the graphs and tables, which could help me grasp the main idea of the research. And then I will review the manuscript again to write a general opinion. And I think to review a paper, it's also a good chance for me to improve my studying. And that's all. Thank you.
Yeah, I think next time we will have we have received the summation that related to your field. I think Dr. Wang will definitely invite you to help do the peer review for the journal. Thank you for the sharing. Now we've seen another question about Dr. Wang. This is also for you. Would research related to climate variability, for example, the El Nino, be considered for publication? Dr. Wang, do you like me to?
Yeah, please repeat it.
Yeah, okay. The question is, would research related to climate variability, for example, the El Nino, be considered for publication?
Yeah, it's okay.
Yeah, so it's welcome, right?
Yeah.
Okay, good. Now move on. Next question is for Dewey. Even if the journal gets an impact factor, it doesn't mean that the individual article will be cited. Not everyone is as lucky as Dr. Yu to have been, for his article to have been cited so many times. So what is your advice to authors to promote their articles after acceptance?
Thank you. That is very true, as you said, that although the citation of ACCR is growing very well recent years, still some articles are not cited. Here I will give three very simple, easy ways for the authors to promote their citation, to promote their research. The first one, I would like to suggest the authors to make best use of the available platforms, websites, to increase the visibility. That's quite important for other researchers to find your research. Easy way you can do it, so you link your research at your institute personnel page, or make your CV available online and with your research connected to the page. Also, it's important to keep your Scopus and OCAD ID page updated. The second one is to present your research at conferences. Presenting gives a face and a voice to your research, and also bring more chances for collaborations. The third one I would suggest is to make full use of the social medias. We are in such a special period of the internet development. But here, but I would suggest to realize the different roles of social media. The first one is the social media like Facebook, LinkedIn, Google Plus. In China also include WeChat and Weibo. On this kind of platform, you explain your research in simple language and highlight the importance of your research. Another channel you can use is to go through the institutional communication like press and the newsletters. This can be more formal. Another way I would supply is that we also choose featured contents to promote. So if you think your content, your research is interest for a more wide audience, you can also contact us for promotions. Thank you.
Thank you. Thank you. Let's ask the last question to end today's symposium for Dr. Wang again. So looking forward, what kinds of manuscripts are you expecting? Dr. Wang.
Yeah. We are looking forward the articles on climate change just from the scientific basis, impacts of climate change, mitigation to climate change, and adaptation to climate change, and also the climate policies and climate governance. Yeah, all of these from a scientific basis to the social science will come.
Thank you. So Dr. Yu and Dr. Luo, do you have any advice to give to for future authors how you can get accepted after submission or during preparing the submission or their manuscripts?
Okay, for my suggestions, I can have the following suggestion. Maybe the potential authors can take it. Okay, the first is that maybe when you want to publish papers, you need to know what is your idea. So you need to search for the published papers in the journals, like maybe the ACCR is a potential selections, and after you have your own idea, is that what you want to do and what you want to write. So this is the first step. And the second step is that you need to write your subject. You need to have many figures or tables. Then after you have your own draft, you can evaluate the importance of your result. Maybe it is a good, if you think that your result is a top result, maybe you can submit to science or nature like that. If you think that okay, your research is more original and is maybe not important because this is your first chance, maybe you can evaluate and then you decide which journal you want to submit. Maybe advance in climate change research is a good choice because it's published papers on recent climate change and also climate evaluations. So the last suggestion is that you can evaluate your own result and then decide which journal to submit. So the first, the main thing is that you need to write and to finish the draft. So this is the first step. Okay. So good luck for your writing. Yeah.
Thank you very much. And Dr. Luo, do you have any input on this?
Okay. I would like to say that to publish a research paper in some academic journals such as Advancing Climate Change Research, it's just like to get our work, our finished work reported by a famous newspaper or on our website. That means we should first try our best to do our research projects. Probably we need to design well for our scientific projects, carefully conduct the field and numerical experiments, and connect and analyze the scientific data and try to uncover the scientific principles or laws, and then renew and review as many as possible about the relevant papers or documentation related to our research. As for me, I'm doing research about permafrost, the spatial and temporal dynamics of permafrost using in situ and observations and sometimes numerical simulations. In my opinion, I'd better to carry out our field experiments and conduct the field observations as good as we can, and then collect the data and to find the change of permafrost and the response of permafrost to climate change. Yeah, that's all. I hope I could have a chance to get my work published again in Advancing Climate Change Research. That's all. Thank you.
Thank you very much again. I think we have to end our symposium by now because we are running a little bit late. I can see that there's still a couple questions about our academic lectures. We have set up a WeChat group for the sharing. So if you have questions for all of our speakers, please join the WeChat group by scanning this code on the screen, and you can pose your question there. Our speakers will be able to answer your questions, and you can get connected with each other. Thank you very much again to all the speakers for the excellent talks and the sharing, and to all the audience for staying with us till the end. It's a long symposium. As I said, we will share with you the recording of today's symposium at our WeChat group, and we will also upload the recording to our Bilibili platform. You can search KEAI, K-E-A-I, and then you will be able to find our account on Bilibili platform. That is the end of today's symposium. We hope that everyone will have your takeaway, either on research or on publication, and even on your daily behavior to curtail climate change.